Hi, this is topic 6.1 here in the energy momentum rotating systems unit. This is where we're going to focus on rotational kinetic energy. So rotational kinetic energy for a rigid system or object, right? Related to the rotational inertia and the angular velocity. So if you remember, this is our translational kinetic energy, but our rotational kinetic energy will kind of take the same form, but we'll use those rotational quantities. So remember, the rotational equivalent of mass is rotational inertia. The rotational equivalent of speed or velocity is angular speed or velocity. So therefore, when an object is rotating and rolling, okay, it'll have both types of kinetic energy. So the total kinetic energy would be the translational kinetic energy plus the rotational kinetic energy. So what does that mean? 1/2 mv squared plus 1/2 I omega squared. Now, what will sometimes happen is maybe you'll get confused because these are rotational quantities. But remember, I is basically mr squared. So there we have linear quantities, and omega is related to linear quantities by v equals r times omega. So you can write 1/2 I omega squared in terms of mvr. I mean, the good thing is that r's will cancel out, leaving only mv in the problem. All right, so a rigid system can have rotational and kinetic energy while its center of mass is at rest due to individual points within the rigid system having linear speed and therefore kinetic energy. All right, so let's look at an example. So we have a wheel with a rotational inertia of I mounted on a fixed frictionless axle. The angular speed omega is increased from 0 to omega f in time t, interval t. What is the average power input to the wheel during this time interval? Okay, so if you remember back in physics 1, power is simply change in energy over time. So we're changing the kinetic energy over time. And so we're going to have 1/2 I omega final squared minus 1/2 I omega initial squared over t. All right. Now, the good thing is omega initial is 0. All right. And so now our power is just simply going to break down to be I omega final squared over 2t. But you have to remember this from an algebra-based course that power is changing energy with respect to time. All right, so other things that you could see here, you can have, they may talk about like what is, how fast is a rolling ball moving down at the bottom of an incline. It could be a ball, a hoop, a disc, right? Any of those. Those are ones, again, the AP test will not have you, won't be on the formula sheet. You don't have to memorize them, although it may be easy to memorize them or easier, but they will traditionally give it to you if they're going to use it. All right, so in the next video, we're going to bring in a little calculus. We're going to talk about torque and work.